now we will discuss unified versus split. So what is unified structure? In which both instruction memory and data memory are present in one memory. Okay, that means one memory contains instruction as well as the data. In split memory, that means one memory is responsible for the instruction, another memory is responsible for the data. So you can say unified cache means in that cache both instruction and data are present. In split cache there is two type of split cache, I cache and D cache. I cache for the instruction, D cache for the data. Okay. Now see some examples based on this. So first one is this one. So where total instruction is 1000 and miss for, and now let's see instruction cache is 16 KB, data cache is 16 KB, unified cache is 32 KB. Okay. Now, so miss for 1000 instruction, in instruction case you are getting 3.82, for the data case we are getting 40.9, for the unified case we are getting 43.3. The information 30%, 36% of the instruction and data transfer, that means load and store. 74% of the memory access are instruction reference. That means if you are thinking about that out of 100% memory access, so 74 memory access because of the instruction. Okay, it is explicitly given. It is explicitly given. If it is not given, also you can calculate. By what? I told in the last class. So by, if it is not given explicitly, how will you calculate? 1 upon 1.36. See, if it is not given, then you can calculate from this also. Okay, if it is not given 74%, then we will calculate what, how? 1 upon 1.36 in the last class we have discussed. Okay, so as it is especially given, so no need to worry about. Okay, then heat takes 1 clock cycle, miss penalty takes 200 clock cycle, load and store takes extra 1 clock cycle on a unified cache. Then which has lower miss rate and compute AMT for each cases. Now, so as it is giving miss for 1000 instructions, what is the miss per instruction? So 3.82 by 1000. So it will be 40.9 by 1000, 43.3 by 1000. Okay. So first of all, we will calculate the miss rate. So this is the miss for instruction for the what instruction cache. This is for the miss for instruction for the data cache. So if miss for instruction is given, then how will calculate the miss rate? In the last lecture also I have discussed. So miss rate formula is what? Number of miss per total memory access. Miss rate is what? Number of miss divided by the total memory access. So if you see the number of miss means what? Number of miss, if you talk about the per instruction, the number of miss per instruction divided by the total memory access per instruction. Now, so for this, if I calculate miss rate for the instruction cache, miss per instruction is 3.82 by 1000 divided by the total memory access. So total memory access will be what? Total memory access for instruction is 1. Getting it? This is what? Total memory access for instruction. Now, miss rate for the data cache. Data cache is equal to what? 40.9 or 1000 divided by total memory access for instruction for data is 36%, so 0.36. Getting it? So this is for the instruction, this is for the data. Now, miss rate for the unified cache. Is equal to So miss per instruction is 43.3 by 1000 divided by total memory access for instruction. So it is this cache is for the instruction data. So you have to add it 1 plus 136. Just see. This is for the instruction set cache. So for the instruction is total memory access for instruction. Total memory access for instruction for data cache is 1036. And this is for the unified cache. Now just compute it. So you will see which has the slower miss rate. The slower miss rate is your. So you should calculate. So this one is 0.004, 0.114. Then for the unified cache, you will get 0.0318. Now, so this is for the instruction data. So how to combine for the miss rate for the split cache, miss rate for split cache. The formula is percentage of instruction into instruction miss rate plus percentage of data into data miss rate. So what is the percentage of instruction? It is already given explicitly 74%. If it is not given, then how to calculate? Only have to 1 upon 1.36. For the instruction reference, it is given 74% explicitly in the question. If it is not given, then how to calculate? 1 upon 1.36. Okay. Now, just put this 0.74 into 0.004 plus 0.26 into 0.114, which is equal to 0.326. 0.0326. Now, which is the slower miss rate? You see, this is 0.0318. It is 0.0326. So obviously, unified cache has the slower miss rate. So unified cache has slower miss rate. Okay. Now, so this is regarding which is the slower miss rate. Now compute AMT for each cases. So AMT for the split. So how to compute AMT formula? Percentage of instruction, cache hit time plus miss rate into miss penalty. So just find out. A percentage of instruction is 0.74 into cache hit time. That means your ideal CPA or cache hit time they give you 1 clock cycle plus miss rate. This is for the instruction. So miss rate for the instruction, that is 0.004. 0.004 into miss penalty is given. Miss penalty is 200 plus 0.26 into 1 plus miss rate for the data cache 0.114 into 200. Okay, so the answer for this one is 7.52. 7.52 clock cycle. Okay, now let's see average memory access time for the unified cache. For the unified cache, so for the percentage of instruction is 0.74 into cache hit time takes 1 clock cycle. So one information is given: load store takes extra 1 clock cycle on a unified cache. So for the load and store, it will take 1 clock cycle extra, but it is for now we are talking about the instruction. So 1 plus. So for the unified it is 0.0318 into 200 plus 0.26. 1 plus 1 plus 0.0318 into 200. So why is this 1 plus 1 plus? 1 is for the hit type, another one for the extra 1 clock cycle. Getting it? So the answer will be 7.62 clock cycle. So now tell me which case has the less average memory access time? So obviously split case. So split case has better memory access time than unified case. Okay, just see what we have discussed. So miss per 1000 instructions is given for each case. So you just calculate miss per instruction. Okay, from the miss per instruction you will able to calculate the miss rate for each case. For the instruction case, so first you have to know what is the miss rate formula. Number of miss by total memory access, or the number of miss per instruction by total memory access per instruction. So miss per instruction already you have calculated. So miss rate per instruction per divided by the total memory access per instruction. 1 for the data 0.36, it is will be 1.036. 1.36. Okay. Now just calculate average memory access time for the split case. So percentage of instruction. Okay. So okay, if you don't know the formula, then I just write down here percentage of instruction, then heat time plus miss rate into miss penalty. So this miss rate is for what? Instruction miss rate, instruction case. Same percentage of data into heat time plus miss rate into miss penalty. Okay. You see. So you calculate average memory access time for the split case, average memory access time for the unified case. So just same formula. Here only one extra clock cycle is needed for the load and store. Okay, so it will be given in the question paper. So this much. So now let's see which memory access has the better obviously split case and which miss rate. So for the miss rate for the split case you have to combine to this. So for the combination the formula is this one, percentage of instruction into instruction miss rate plus percentage of data into data miss rate. Okay. So this is the one example. Now we'll see another example for this unified versus split. This is the second example for the unified versus split. So here instruction cache size 16 KB, miss rate is given, data cache size 16 KB, miss rate is given, unified cache size, miss rate is also given. Now it takes 1 clock cycle, miss penalty takes 50 clock cycle, 75% of the instructions reference. Okay, that means 75% of memory access at the instruction reference. Load and store takes extra 1 clock cycle on a unified case. The question is which has a slower miss rate and compute AMT for each cases. Now see, miss rate for each case is given. So now just combine this for the split case. So miss rate for the split case is equal to, so percentage of memory access because of the instruction 75. Okay. Now then miss rate for the instruction 0.64 by 100 plus percentage of data, so 0.25 into 6.47 by 100. Okay, you just calculate this thing, so you can answer will be 2.09%. That means 2.09 by 100. We get 2.09 by 100. Okay. Now, so which is a slower miss rate? So 1.99 or 2.09. Obviously unified. So unified case has slower miss rate. Now we will calculate what? AMT. So AMT for which case? Split. So for the split. So percentage of instruction is 75. Hit time 1. Miss rate for the instruction is 0.64 by 100 into miss penalty is 50 plus percentage of data 1 plus 6.47 by 100 into 50. This is your average memory access time for the split case. Now average memory access by time for the unified you will get 0.75 1 plus 1.99 by 100 into 50 plus 0.25 1 plus 1 plus. So 5 1 plus 1 plus here it is given. For the load and store it takes 1 clock cycle extra in unified case. So this part is what? Load and store data percentage of data. So plus 1.99 by 100 into 50. Okay. So you can see that so split has the better performance than the unified case. This is how we are calculating average memory access time. Now the third example. Now in example 3, so it is same as the example 2. Only one line is exchanged here. In that percentage of memory access the instruction reference is given 75. Here in that case it is given 33% of data operations are the load and store. Okay, at the load and store. So what I have said, if it is not given explicitly for the percentage of instructions, how will find out? How will find out? 1 upon tell me total memory access. Total memory access is what? 1.33 for the percentage of instruction. Now same as for the percentage of data, it will be 0.33 divided by 1.33. Okay. So from this you just put the values, you will get 75% mostly. Okay. So just put the values and you will get the answer. So only the changed line will be this one. In this line, so here is 33% of load and store. In the previous example, it was what? 75% of memory access are the instruction reference. Okay, so that's it. Okay, so this is regarding your unified versus split case.